Today we're going to be talking about the discriminant, and the discriminant is the inner part of the quadratic formula, and I've highlighted it down here in blue, in light blue. So the discriminant right here is b squared minus 4ac. And the purpose of the discriminant is to help us quickly identify what kind of graph we are looking at, and secondly, what kind of solutions we are going to look at. And these solutions are going to have either two qualifications. They're either going to be real or imaginary. So a couple things we need to remember when we're looking at the discriminant. We need to be first considering that we're going to be working with the quadratic equation that's set equal to 0, and that will then allow us to very quickly figure out what kind of solutions we have, real or imaginary. So I made a little table down here at the bottom that'll help us to very quickly identify what kind of solutions we have. So the first scenario that we're going to consider is what happens when b squared minus 4ac, the discriminant, is positive. So if the discriminant is positive, we have a couple implications. The quadratic formula, you remember, is going to be then plus or minus the square root of b squared minus 4ac. Well, what happens if that inside is a positive number? Well, we're taking the square root of a positive number. That's going to be some type of a decimal, or it might turn into be a perfect square, which would work out nicely. But in either case, we're going to end up with plus or minus the square root of some number. And therefore, we're going to have two answers, and both answers are going to be real numbers because you can take the square root of a positive. Now, implications on our graph, we're going to have two solutions, whether the graph is facing upwards or whether the graph is facing downwards. And so it doesn't matter, but either way we're going to have two solutions. The second scenario that we're going to have to consider is what happens when the discriminant is equal to 0. And if the discriminant is equal to 0, then the quadratic formula becomes the opposite of b plus or minus the square root of 0. And so what this means is we're going to have to deal with the idea of the square root of 0. Well, what is the square root of 0? That means it's going to lead straight to just dropping that out, and your answer is going to be the opposite of b over 2a. And only in this case, obviously, therefore, that's going to give you one answer. That answer is going to have to be real. How does that look on a graph? Well, the graph might go upwards like that and touch at one point, or the graph might be pointing downwards and just touch at one point there. But either way, that vertex touches the x-axis in just one point. So our third scenario about our discriminant is dealing with the situation that the discriminant might be a negative number. And this is going to occur if we have plus or minus the square root of a negative number all over 2a. Implications of this, we're going to be taking plus or minus the square root of a negative, which is going to come out as an I times some square root of a number. What's this going to lead to? Two imaginary solutions. Specifically, they are not going to be real solutions, but instead they're going to be two imaginary solutions. And as we look at a graph, then that means the graph is not going to be touching the x-axis at all. Because if it touches the x-axis, as we've seen in our other scenarios, that will give us real solutions. Now, let's look at our next page where we've got 4 problems that we're going to experiment with to determine what the discriminant is to very quickly tell us what kinds of solutions we have. Now remember, your discriminant is based on the fact that you're going to have ax squared plus bx plus c equals 0. In other words, the whole problem needs to be equal to 0. And we're really worried, does b squared minus 4ac, is it positive, is it 0, or is it negative? And those are our 3 possibilities for working. So here we go. First problem, x squared minus 3x plus 4. That means a equals 1, b equals negative 3, c equals 4. So we quickly take the square root of negative 3 squared minus 4 times 1 times 4. That's 9 minus 16, or the square root of negative 7. What does this lead to? Because it's a negative number, the implication is we have 2 imaginary solutions. Now, I took the liberty of graphing this. I wanted to show you what this graph looks like. And so here's our equation, y equals x squared minus 3x plus 4. You'll notice the equal sign right here is highlighted in black, which means the graph is going to be active. And so you can see that we have a graph that is not crossing the x-axis, and that is an indication of what we already knew because the discriminant was a negative number. Let's look at B. Here we have x squared minus 8x equals 16. Well, I'm going to start by taking this and I'm going to bring the 16 over so the whole thing is on the same side of the equation. A equals negative 1, B equals negative 8, C equals negative 16. Now I know you could have brought everything to the right side of the equation, but I wanted to deal with a negative A just as a possible scenario of the problem. So B squared is negative 8 squared minus 4 times negative 1 times negative 16. 8 squared is 64. 3 negatives make another negative, and 4 times 16 is another 64, so we have the square root of 0. Well, since the discriminant is 0, that is going to lead then to only one real solution. When does one real solution occur? When the graph comes down and touches the x-axis but does not go further. And so here, if we go back to our y equals, I'm going to unhighlight this problem by hitting the equal sign and go down to our next equation and highlight that equal sign and make it black. And now we can look at this graph. And now we can see that the graph comes up, touches the x-axis, and goes back down and only touches in one point. All right, now a quick review. If we wanted to find out what that 0 was, we could hit second calc, go down to 0. We could put our cursor on and move it across, and see here we have the spider coming up and going to the left-hand side. We hit enter. We move the arrow and the cursor over to the right-hand side, hit enter again, and we hit enter a third time for our guess, and there it jumps right to negative 4 point multiple zeros 0.2. Now, the reason it's not exactly negative 4 is because our calculator is not 100% accurate, but only accurate to a certain number of decimal places, because the answer actually is just negative 4. All right, well, let's look back at our third example. Our third example involves x squared minus 6x. On this case, we have a equals 1, b equals negative 6, and c equals 0, because there's no constant. So my discriminant is negative 6 squared minus 4 times a times c. Well, that leaves us missed with negative 6 squared, which is 36, because the 4 times the 0 cancels out. Obviously, this is a positive number, and the square root of a positive number naturally is going to lead to two real solutions. They might be square roots, they might not. In this case, they are going to be rational numbers. Let's go back to our graph and look at what the graph of this one looks like. So we go back to our y equals. We're going to come down to our second equation and unhighlight the equal sign, which turns it off. Go down to our third equation and turn that on. And then we'll look at the graph of this. We're going to see that the graph of this is going to cross 2 times. As you see, it crosses at 0 and at 6. Okay, moving to our fourth example. We have x squared minus 5. Well, that means a equals 1. There's no b term, so b equals 0, and c equals negative 5. Let's find the value of the discriminant. 0 squared minus 4 times 1 times negative 5. Well, that's 0 plus 20, which is definitely a positive number. Being a positive number, once again, I hope you realize that this is going to lead us to two real solutions. What does this mean in terms of our graph? That means the graph is going to cross the x-axis twice. So let's take a look at what that looks like. We go back to our y equals again. We're going to uncheck or unselect the equal sign on the third equation and select it on the fourth equation. and then we're going to take a look at the graph of this. And we're going to anticipate it's going to cross twice as it does. And you'll notice because it's x squared minus 5, it's symmetric and centered on the y-axis. So, as we've looked at our discriminant ideas, we have 4 examples, each different scenarios with a's and b's and negatives, and we're looking to see whether the discriminant is going to be positive or negative or 0, which leads us to either 2 imaginary solutions, 1 real solution, or 2 real solutions. I hope this has been a quick informational piece. At the bottom, we've referenced the other day about a chart in terms of what method to best use for a solving quadratic equation. Well, when you're graphing, that's a good thing to use when you do not need an exact answer, but just an answer that's rounded to maybe to the nearest 3 decimal places. Factoring, simple and easy. Work for no more than a minute on factoring, and then if you can't, go to another method. If there's just 2 terms and both have variables, like an x squared and an x, look to factor out an x as a greatest common factor and solve. If there's 2 terms and there's no bx term in the middle, look to take the square root of both sides after you isolate the x squared term. If the a value is 1 and the b term is even, completing the square is your answer, but if all else fails, the quadratic formula is always going to work. So, our worksheet tonight gives you multiple different options to do. I've emphasized to do a couple different options on certain problems, but on most of them, you're going to get your chance to do and choose at the end of the problem. I hope this has been helpful in working out the problems, and test is going to be coming up on Tuesday as we look to finish up our chapter.